Hey everyone, thanks for coming to the panel. I think this one is going to be maybe a slightly more lighthearted one. EVM Quirks. Obviously, we've had the entire day to talk about why we all love the EVM, and now maybe it's time to talk a little bit about why sometimes the EVM can also be a little bit exhausting at times. And maybe to start with, I would just want to go through the round, kind of have everyone introduce themselves and talk a little bit about kind of this specific background and the exposure to the EVM. So maybe start with you, Matt.
Sure, thanks, Ansgar. Hi guys, my name is Matt. I go by Light Client on the internet, and I work on the Go Ethereum team. I've been with them for about 1.5 years now. Before that, I abused the EVM on the Quilt team with Ansgar for several years, writing an EVM assembler called ETK, and just always trying to push what we can do with the EVM and try and do things the way that it wasn't designed to be used. I think one of my favorite things that I've been able to do is just never use push 0 previously to it being introduced, always using return data size as the best way to get 0 into the stack.
Hello everyone, my name is Dragan Rakita. I was maintainer on Open Ethereum. I'm author of Rust EVM, and for the past year I am part of Paradigm, and we are building Rust Ethereum. That's basically it.
Hi, I am Ayman. I'm from Nethermind. I work on mainly the EVM in the Nethermind client, and I usually pick good first issues that are related to the EVM that end up being too big, like the EOF.
Hello, I'm Peter Davis. I work for EELS, which is the Ethereum execution layer specifications, and we're basically writing a new executable specification for how the EVM works. A lot of that work has involved me being a bit of an Ethereum archaeologist, digging up the weird bits of past history and investigating the weird corner cases. I've been writing this specification.
Hi, I'm Daniel. I've been with the Solidity team since 2018. Last year I took over the lead from Chris. So I'm the sorry person who has to generate code that actually runs on the EVM in the end. That's my connection.
Okay, good. Yeah, one first question that I would want to ask to get us started is, so we have 3 people here from 3 different clients. Of course, implementing the EVMs is basically one particular side of the stack versus kind of then using it. So I'd be curious, kind of from your perspective, what are the most challenging aspects about the EVM, or from a client perspective, or what basically, I don't know, what gives you the most headache?
Testing it.
About the EVM.
I think testing the EVM is a pretty challenging aspect of working on an EVM implementation. I mean, you've also had to write some tests, and the various frameworks that have existed over the years. We've had this Ethereum/test project for a long time that I can see people in there shaking their head in the audience. And writing tests for that was quite a journey. We've sort of had a new project step on the scenes. This is Ethereum spec tests, which is a bit more of a Python-based testing framework, which I think has been really helpful for improving the velocity that we can develop EVM features. But honestly, I mean, on a Go Ethereum, a lot of this stuff is on Rails. Martin has sort of built a good framework for developing features in the EVM, and now adding things to the EVM is not so difficult. We try to keep it as simple as possible, so that it's very easy to reason about. There's not anything that can really jump out that you weren't expecting to happen behind the scenes of a more complicated implementation.
Yeah, maybe if we go from kind of the oldest client and then we work our way through. So, Ayman, if you want to talk maybe how Nethermind.
Okay, so I kind of agree about testing. Testing is always a big pain point for us too. And yeah, since tests are usually late compared to the spec, and there's also the frequent changes in the spec that happens when the specs are not yet finalized, and sometimes in EOF after they are finalized. And those are kind of a little bit annoying, especially that there is no tooling that notifies us when an EIP that we are watching or we are interested in changes. And that
I think the tooling is sitting right there.
Oh yeah, he suffers from the same pain with me since we take care of this stuff. So yeah, that's probably the main pain point for us. Implementing the specs is usually not that painful because it's just patterns. The same way we did it before, we'll do it again, and we'll keep doing it forward. But the stuff keep changes at a frequent rate that sometimes it's better to just wait and sit in a stalemate until everyone reaches some consensus around some stuff and then tackle the work at once and for all. And yeah, that's my point of view.
Right. That makes sense. And Dragan, maybe I'm curious in terms of, I think Red was the first client coming to the EVM when it was already a somewhat more mature virtual machine. So does it mean that maybe your experience, I mean, I guess you already had previous experience, but do you think that made it easier, or what do you say kind of the work on the Red side?
Basically, supporting old hard forks was very hard. Basically, state clear was the nightmare, self-destruct was the nightmare. Basically, first iteration, I had a big bug of self-destruct because I didn't know how it functions. And like, there is a lack of like documentation that could explain that, and you can look at the code. But it's like you're transitioning between the language that you know to the language you are maybe not that familiar. That was the big pain point. I want to say that tests were very great. just to say your effort is like very, very like appreciated. Yeah, that's mostly it. Supporting like, it's not just EVM, it's like outcome of EVM. How you support multiple transaction, how you want to cache it, how do you want to do like, to do it in like optimized way. All that's like a lot of complexity that piles up.
Right. I think, Daniel, we talked a little kind of in preparation for this already. I'd be curious, obviously you're the only person here that actually ends up consuming and using the EVM. The EVM is quite a unique virtual machine, so when you kind of think about the constraints that puts on what you can do on the kind of the compiler side, what are like the main aspects of the EVM that maybe constrain you the most or that cause you the most headaches?
Yeah, I mean, in general, it shows that the main idea in designing the EVM was usually more towards client simplicity and implementation simplicity and not towards generating code that actually runs on the EVM. That's something that we then need to deal with, which, yeah, it's hard even to pick the one that's the most annoying. The stack access being restricted to 16 slots is for us particularly a huge problem. Memory pricing is a problem. But yeah, there's one quirk after the other in that sense, so yeah.
Right. Yeah, I think in the early days of Ethereum there was a lot of hope that this was just like a very rough first draft of a virtual machine and we would quickly just get rid of all of these kinks. At this point, how do you think about the situation of the EVM? Do you think we will just be stuck with most of these issues forever, or do you still hold out hope?
I mean, we were a big proponent of EOF last year and spent a lot of effort implementing the version at that point. I think still, if that ever has a chance of actually getting to chain, we would still be very much in favor of that. That solves most of the problems we're having. Not that all of it will be a piece of cake afterwards, but it will be a significant improvement for us. So still having some hope of that happening, but yeah, the past has taught us to be cautious in expecting it to actually happen. So it would be nice for us to have some guarantee in that sense that we can actually build implementations, because that's a significant amount of effort for us. But yeah, apart from that, that's the only path I see recently to expect significant improvements. Otherwise, we will be stuck with a lot of complexity on the compiler side.
I think the big challenge that the EVM has is that like we're stuck with technical debt forever. We can't ever like deprecate. It's very difficult to ever deprecate anything because, I mean, firstly, the old hard forks will still have to implement it, and secondly, like if there's code that like depends on that one weird feature, like, can we break people's smart contracts? I mean, this caused a huge argument with self-destruct. I think the only thing I'm aware that like is like really heavily deprecatable was that the empty accounts that the ref person was talking about is like is like a nightmare. The complexity of that system, the weird edge cases are insane. And I think that like I actually went and deleted those accounts, and so that's one of the really rare cases where we can actually say no, you don't need to worry about this anymore. But like usually, once you add something to the EVM, you're stuck with it forever.
Right. Maybe this is, yeah, if you.
I was just going to say, I mean, is that an argument that we shouldn't do EOF? What happens if we do something wrong? Now we have this huge mutation to the protocol that we'll always maintain.
I mean, it's not that huge of an update, really. It looks larger than it is in that sense of that most of the opcodes actually stay the same as before function-wise. And I mean, the problem about the complexity is also, I mean, that doesn't just vanish. I mean, if we don't change the EVM, the complexity just moves to a different layer, and it is then that maybe have some advantages, but it's still also not great that any language you implement has to deal with all the quirks in the EVM, making implementing, I mean, there is not a large diversity of languages for the EVM, which is also a problem, which is partly towards it just being hard to implement languages on top of the EVM at the moment. So, I mean, it's a trade-off there where I'm not sure that it's, I mean, I'm of course extremely biased from the one side, but I mean, yeah, maybe it should be more of a thought also to consider the complexity after the EVM itself, that actually the state of the EVM imposes.
Right. Maybe a question there because obviously, oh, do you want to jump in? Sorry.
Yeah. Basically, if you want to evolve something, you need to introduce new complexity. It's like, it's painful, and every client, every like EVM implementation wants to support everything. I basically started RAM only like supporting last 3 hard forks, but it was like always the question, hey, when you are going to support, I don't know, hard fork from 5 years ago? It's like, it's every client is going to implement all hard fork because it's like there is a requirement, not requirement, but it's like the next step of EVM implementation. So for the future, we shouldn't be like, there's going to be new stuff that are going to replace old stuff, and that's perfectly fine. But that's the only way how to evolve EVM a little bit more, so that it can be usable for more people.
And hello. And also for EOF, it's a very good like progressive step for the EVM as a whole, since it makes it easier for us as VM developers to assume stuff about the bytecode before deploying it, so we'll know more about the bytecode as we deploy it. And for the compiler developers, they will also have a more structured bytecode to emit, since right now the EVM bytecode is completely dynamic, which is, it emulates subroutines using dynamic jumps and jump tests, which is kind of bad in a way, to say the least. So with EOF, we will have subroutines, we will have stack validation. Probably we can then, the compiler can then inspect the bytecode, have more assumptions to do better optimizations. The VM can also do that stuff while analyzing it before deployment or while executing it. It will probably make what the previous presentation discussed about native code emission or JIT code emission. It will make it probably easier, or at least easily researched compared to how it is right now with these dynamic checks, these dynamic jumps to emulate subroutines, and at least having statically resolved static jumps compared to how they are done right now with push and jump tests is in itself a better way to do stuff compared to how it's done right now. So EOF might be big or might be complex to add, but I see it as a necessary step to do to improve the EVM. And progress, I guess, moves forward. We cannot stay stuck in the same state because the next step is a bit difficult. And as I think, I read somewhere that simple systems may give rise to complex phenomena, and this is how the EVM right now is. It's simple in how it is defined, but in order to use it, we end up using very complex structures just to emulate stuff that should have been there from the get-go. And yeah, that's, I guess, my point.
I think like the big curse you have here, though, is that when you implement EOF, you can't just snap your fingers and get rid of the pre-EOF EVM, which means that you've got all these people who've like done all these complicated things to like work around the mess and the difficulty of like developing EOF, work on EOF, but then you have to, then now they still have to support that, and that applies, I think, both on the compiler side and on the client side. And they have to support that, and they have to maintain all that stuff, and they have to keep all this stuff, even though they also have to generate and operate with this code that doesn't have all those problems. But then they have to be able to take advantage of not having to make those assumptions. So you just end up with, like, if you're going to be fast, like 2 of a whole bunch of code paths.
Well, maybe to just frame that question, I think we were talking about EVM quirks. I think one interesting aspect here is that it seems to be that we have 2 different types of EVM quirks, right? We have the user-facing, the compiler-facing quirks, and there the hope is that in future versions we can just add functionality and then those quirks go away, because then at least we can just use these features. And then we have the maintainer, the kind of the actual the client side, where adding new features only ever basically increases the list of quirks you have to deal with, right? Because it's great and all that Solidity now no longer has to deal with it, but now you still have to support the old version and the new version. So it seems basically like there's 2 different sides to the quirks. Maybe Daniel, on this compiler side, I'd be curious. In the existing version, do you consider the quirks more like minor annoyances, or do you think they're like actually like strong and significant hindrances to basically really using the full potential of the VM? And if it's the latter, like to what extent do you have hope that this can be addressed with future improvements like EOF?
It's not minor things. It really makes it hard to implement compilers for the EVM. That's kind of like, there's no sugarcoating that. I mean, EOF would kind of like strike off a year of work for us in trying to work around Quirks, for example. I mean, it's really significant changes. I mean, for us, the maintenance burden, of course, immediately vanishes. I mean, EOF-generated code from us is better in every aspect. So, I mean, it will be cheaper, more analyzable, and better in any aspect. So, we will maintain the old code path generating legacy code, but I think nobody will use it in a very quick time, actually. I mean, so for us, it's...
Laughs in the audience.
For us, it's, of course, a 100% positive. Of course, that's price paid in client complexity. That's, yeah.
And there is, like, as an example for a quirk or a pain point that will die, hopefully with EOF, is the stack too deep exception in the compiler. If you use more than 17 or 16 arguments in a function, you'll end up with an exception, because we have swap and dupe that go up to 16, but they can't go beyond. So you can't manipulate that deep in the stack, and you will end up with an exception. There is swap n and dupe n opcodes that might make it in EOF that increase that range a lot. So just adding those 2 opcodes and will remove this pinpoint at least. So that's one. CallF, retf will introduce functions as well. So yeah.
And I mean, I think just because the theme of this panel is a little bit more actually diving into these quirks, can you maybe briefly explain why EOF would enable intermediary arguments for opcodes, and basically why that has not been possible so far, and why that's basically...
Okay, so right now, if we want to manipulate or bring an item from a certain point in the stack to the top so we can operate on it, we either have to pop until we reach it, which is kind of not ideal, or we can swap it with the current top. So if we want to swap it, we have the swap opcodes, and they go from, I think, 1 to 16. And that means that we can swap only up to 16 items, and we can't go beyond that depth. So if we need more, if we need an item that is beyond that range, we definitely have to pop, or we just do the easiest way, which is, no, we can't do it. We throw an exception. You used more arguments than it's allowed. Even though theoretically, we should use as much arguments as we need in a function. Probably if you have 16 arguments in your function, you are doing something wrong. You have to abstract something somewhere, but if you want to use it, you should be allowed to use it and pay the price in gas, I guess. In EOF, we are introducing, I think in EIP 663 or something like this, we are introducing an alternative to these opcodes that is kind of a little bit generic in the range. So instead of telling it swap 16 or swap 13, we call it swap, and then the depth we want, that I think goes up to 256. And we can get that item and swap it with the head, which means that right now, if you reach a function that has 256 arguments, you are doing something wrong. It's not an assumption anymore. So refactor your code.
It's not like it's only functions with that many arguments. You also need to store intermediate computation values somehow.
Oh, yeah.
And somewhere. And I mean, people want to have us optimize code, which means inlining code, especially with highly priced jumps at the moment. Jumps are overpriced insignificantly, which means we need to inline stuff. Then the amount of local variable increases, which quickly grows beyond 16. So we need to do global analysis of the control flow graph and the backwards analysis to try to construct optimal stack layouts to run into these issues as late as possible. That's huge complexity. And even that's not enough, and then we need to try moving variables to memory from stack in some cases, which also is a lot of complexity, and luckily we didn't have a bug in that complexity yet that's discovered, but yeah, all that would be solved by this tiny change in the EVM level, which, yeah.
Well, talking tiny changes, I think you, Matt, you kind of representing the Geth team, were the most maybe cautious about more sweeping changes like EOF, or just changes that require a lot of extra logic now on the client and whatnot. Obviously, Geth is the client, the remaining client that has been around the longest. Can you talk a little bit about the way the team, or you personally, think about adding features and kind of the aspect that you have to then support them forever, and the way that kind of that grows the complexity of the overall client architecture?
Yeah, I mean, I don't want to speak on behalf of the entire team, but I can say how I feel about it. And I do think about it sometimes that it's going to be crazy in 20 years when we have a switch statement of 40 different forks. And we have to go through to figure out which branch of code we have to execute for which fork. And I mean, hopefully we find some way of getting rid of the old logic for old forks and stuff, but it's something to keep in mind. What if we don't figure that out? Do we want to maintain some piece of like Swiss cheese code that looks like this? And how do you do this in a secure way? It's definitely a concern to me. And adding new features, there's always the question like, are we going to be able to do this in a safe way? And fortunately, the EVM is probably the place that we are the best at changing of all things in Ethereum. I mean, right now I've been working on 4844 a fair bit, and we're sort of seeing like we're having to develop new testing tools to test the networking of transferring blobs across the network, transferring transactions across the network, and these are tools that we didn't have or need until now. Whereas like EVM testing is something that we've had from the beginning, and yes, it's evolved over time, but we are pretty good at it. And so, yes, I don't know. I guess like testing is a concern. And we are good at it, but it could still break. Like, no testing is perfect, and every time we modify the Ethereum protocol, there's risk. And we've been fortunate that we've had amazing people working on this protocol up here in the audience, and we haven't had a major issue. But EOF is a big change, and it's possible that we have some sort of network split because there is an issue. And we just have to balance that with like, does it bring enough benefit that the risk is worth it? Are we good enough at like testing these things? And I mean, we're probably better at testing EOF than we are at testing the merge or testing 4844. Like, these were like much more emergent types of things, and we generally feel a lot better about that. But then like on EOF, like my big question is this like going to be a 10x improvement for users on L1? And I think like in some instances it probably is. But like we have very, biased people who, they make all the code that runs on, most of the code that runs on Ethereum, and it would make their lives a lot better. But we also have to think, like, what if we had 100 times more data throughput of Ethereum, and Optimism was able to run the super chain, you know?
I mean, EVM compatibility of layer 2 chains just percolates the problem. Then, I mean, you don't have only the same problem on the layer 1, but also on all other layers, which actually is even more reason in my mind to change it on layer 1 as well, because that's currently how it works, that you have the compatibility that, that is targeted. But yeah, it's also not only us as compiler people who want EOF, it's also kind of like auditors, formal verification, and whatnot. I mean, ask those people, and they will tell you they're all in favor of this.
Yeah, I would love for more of those people to like engage with the process, because I do think that's a place that EOF is extremely useful that hasn't really been communicated quite as well to like core devs, and it's something that you can't exactly put a number on how much more secure and how much better static analysis is, but if you have people who are able to like continue showing, look at what it's like to audit, like, I mean, we want to write secure contracts, and if you can write more secure contracts more easily, then we want to be able to show that, and that's like a big piece of making this decision on should we add this to the protocol or not. But you know, to your original point, like L2s also have to deal with these types of things. I think it is like a little bit nuanced, because in the L2 world, like the way that we are designing these optimistic rollups and some of these ZK rollups, we don't have to rely on like every single user running every single transaction. Whereas at L1, it's important that everyone who wants to interact with that chain is like fully verifying the things that are happening on there. Or in the optimistic world, you're just making the assumption that one honest party is doing the thing. And so you can raise the computation requirements to run the chain, do it in, you know, a supernode type of setting where you have a very beefy computer doing these things. And I think that that's still generally okay given like the security parameters that we're trying to understand. And so in that world, having a super performant VM is a little bit less important, because you can just vertically scale what you're running it on a bit more than we can on L1.
I think the other thing that's coming out a bit in this panel is that there's like two very different ways to like look at the EVM. You can look like from a user coming down who wants to run stuff on the EVM, and you're like, what's complicated, what's difficult about the EVM? And like you can be like people like me who are looking like up from people who have to implement the EVM and asking how does the EVM work, and their like perception on Quirks is like actually completely different. Like I didn't even think, I barely even think about the fact that there's like only dupe only goes up to 16 and swap only goes up to 16 is a complicated thing. It's like there's a table, there's a list of opcodes up to 16. Not complicated, whereas you talk to Daniel, he's like, I suffer so much for having to deal with this. At the other extreme, like there are things I deal with, like the question of like the inconsistency about like some buffers, if you read them out of bounds, they're just padded with zeros. Other buffers, you read them out of bounds, it's an error. And like it's a bit arbitrary. And there's loads of like weird edge cases. If you write a zero length write into memory, it doesn't extend the memory, but even if the memory's out of bounds, and that sort of thing, which like don't affect Daniel at all, because Daniel's like, this is a met, mostly. Okay, but like, you know, a lot of these things like don't affect people above because they like don't generally do them, and it doesn't matter what happens. Whereas from my point of view, like you have to think about these issues, because we have to implement exactly the same, even if the code is doing something utterly ridiculous and perverse that no one would ever do.
I mean, just a quick note on that. I mean, we're also optimizing stuff, and for that, this stuff comes up as well. I mean, if, for example, I have a return data copy, that copy is out of bounds, and nobody ever reads that back. We can't remove that, because it could be intentionally going out of bounds and reverting. For call data copy, we can just do that. We can just remove it. So, I mean, optimizing brings in different quirks that then, yeah, also become relevant, just as a side note.
Right. Peter, maybe you've obviously looked a lot through the history of EVM changes as part of the specs work. A lot of what we talked about now touches just governance, you know, how do we decide what future changes to make? Can you maybe talk a little about how maybe the type of or the way we used to do EVM changes kind of has changed over time, and how I think you told me a story once about how in the early days there was a lot of more informal changes but not that well specified, and how that caused a lot of issues as well.
Well, yeah, it is interesting. So, like, my job is to, like, basically try and write, like, a single definitive executable testable spec. Because the history of, like, the spec is that it's, like, disorganized and there's lots of mess. Like, there's the yellow paper, which lots of people think is pretty incomprehensible. It was never updated on time. Like, people would be like, oh, the yellow paper is the definitive spec. And I'm like, yeah, but you shipped the merge, and you didn't put the merge in the yellow paper. So surely if the yellow paper was the definitive spec, like, you'd have written it, like, near the beginning. The other problem that you have, and then you have all these documents that you have to go and compare, and it gets difficult when you're in a situation where you're like, well, I have these two documents that tell me how these two changes work. But what I don't have a document that tells me is what the interaction between that change and that change is. Like, these are not independent. If you do both of them, there's an interaction in the middle that you have to think about. The other example that happened is that, like, you get lots of situations where, like, you're relying on, like, tests as, like, your specification, or you're relying on just reading, like, the Geth source code, which you kind of feel you failed at specification if, like, the thing you have to do is read the Geth source code. So there was a change to the gas pricing for ModExp. And very helpfully, the people who wrote the EIP provided code to explain how it worked. The problem was no one had ever tested this code. And it turned out that the code in the EIP was wrong, which when we were in the bizarre position of, when we implemented this, having to submit a fix to the EIP so the code matches the written specification. And then of course, in the process, you go, well, how did other people deal with this? And you read the Nevermind source code, and then the Nevermind source code, there was a comment that goes, like, we don't really understand why Geth does this during this calculation, but given that Geth does this, we probably ought to do the same thing. And so you just kind of like, okay, we need to, like, get a handle on this and, like, have a more formal process so that these quirks can be understood, because otherwise they're, like, bedded in, like, weird deep knowledge of, like, devs and, like, various people's source code, and you have to then go and dig and go, what's actually going on here?
You don't like a good treasure hunt?
It can be. I once emailed Nevermind to complain that I thought they had a security bug in this, like, really incompetent edge case. And it turned out that what Nevermind did wasn't a security bug. It was just, like, I didn't quite understand their data model. But it was just a bit like, how do you comprehend this? And, like, this weird edge case I've found, and you're just digging through, like, code going, what the hell's going on here?
There was one thing about precompile number 3 that was like, yeah, it's like, I think every EVM had hard-coded precompile 3 because it was pushed on the Gurley, and it's like it had some bug, and it was fixed later, but the Gurley basically continued with that bug. About what's empty state on precompile, something like that.
Yeah. So the ripe ND touch, which was, like, it's one of the, like, craziest failures. So there's this thing called state clearing, and what state clearing says is basically, for annoying historical reasons, people went and made loads and loads of empty accounts. These are accounts with no nonce, no balance, no code. They're basically completely useless. They should just not exist. The problem with this, and so they wrote a client that basically said, if while you're doing EVM execution, you come across one of these empty accounts, you try to make a change to it, but you don't actually make a change, so you add zero balance to it or something, it is declared touched, and it gets deleted. And there, like, because of the rush circumstances this happened in, the specification for this was not clear and full of very confusing edge cases. And so during one of these the clearing, there were situations where touches reverted out of gas, and then it wasn't clear. Well, if you touch it and then the touch reverts out of gas, does that mean the touch and the deletion don't happen, or do the touch and deletion happen? this caused a chain split. And like eventually like Geth got fixed. But there was another bug that no one noticed for a while, where both Geth and Paradigm, who were the main clients at the time, had the same bug. And they were both clearly wrong, and it was very clear that like this touch had reverted and shouldn't occur, but both of them had let the touch occur. And so this then was like, well, what do you do to the specification? And what they did, ridiculously enough, was they decided that the account number 3, so the account with address OX, lots of zeros, 3, is magic and special, and is specifically exempted from the rules about the version of touches. So when you're reverting a touch, the rule is you have to make sure that you are reverting, that the thing that has been touched is not free. Because if it's anything other than free, the touch is reverted. But if it is free, then the touch isn't reverted, which is necessary to like support history, but like it's just kind of insane.
Some of random things inside EVM.
And also there is the recent EIP, the 4788, 4788, the system transaction stuff in mainnet, and we had like a big difference around what do we do with the system accounts after we're done with the transaction. Do we remove it? Do we keep it? What should be done? And I guess we had system transaction already implemented for Gnosis, and we implemented them in a certain way, and then Geth implemented them in their code base in a certain way, and we ended up differing on what do we do with that system account now. I think we ended up doing exactly as we did before. Let's do what Get does and hope they are correct. But yeah, it's still being discussed, I guess, and hopefully clarified in the spec, so we do what the spec does this time.
I think that the other thing the audience won't appreciate here is that the conversation that Ivan is having about where do you delete system accounts is entirely academic, because no one could create any more empty accounts, and all of the empty accounts are deleted at this point. So, like, it's not possible to reach this edge case. It cannot happen anywhere in any production context at all. But the challenge is, because we have this quirk in the EVM, like, are we required to test this? And you get some very weird cases where, like, there's some situation that is like, it's impossible, it requires, like, implausible situations involving people finding SHA-free collisions. But someone wrote a test for it. And now someone wrote a test for it, everyone has to implement this. And so you end up with comments in our EVM where someone goes, well, we're doing this because like we have to pass this test. We don't understand why this test can happen. And indeed, that's because it's impossible to reach the situation that this tests. But there's a test, so we have to like deal with it. And so you end up with this question of like, what's the scope of stuff that we should define in the EVM? Because it would in some cases be nice to just say, look, this particular pre-state, this particular setup can never come about. So we're not going to tell you what you have to do so that clients don't have to put in code to deal with these like weird edge cases.
Right. I think this is a good kind of point too. So basically, not only do we have the EVM, right, where everyone has to support that one specific current version of the EVM, but basically there's 3 different ways in which you basically have to also support alternative versions. We have just like all the historical versions of the EVM from the launch of mainnet all the way through to today. Then more recently, now we also have layer 2s, and so we have all these other EVMs that now also might have subtly different changes, and to some extent clients choose to just ignore that and have other people then build on top and support that, but sometimes clients also choose to support that as well. And then with UF, if we end up bringing it to mainnet, then we also will introduce version bytecode on the chain. So now even within a single EVM chain, a version, you would still have to support multiple different types of contract execution.
Don't forget about testnets.
And then we have the testnets, which same thing as rollups basically, just yet more chain with subtly different rules. So we talked already a little about quite a bit, I guess, about EOF and kind of the tensions there. Matt, you briefly referred to in the past about like kind of historic EVM versions, and how do you think about, obviously they're not strictly necessary if you just want to follow the chain today, but of course if you want to sync, you need to basically still be able to speak them basically. How do you think, like, what is the situation there today about backwards support for all these legacy versions, and do you see this only ever growing, or do you think at some point we can somehow get rid of legacy support like that?
Yeah, I would be curious to hear what other clients have to think about this, but we've thought a little bit about this through EIP 4.4s, which is this history expiry idea, and thinking about sort of the end game of that EIP. And what I could imagine seeing in the future at some point is some sort of software that multiplexes many historic binaries of a client. And so we might have this future where the latest version of Geth only supports the last 2 or 3 hard forks. And if you want to fully validate the chain sort of beyond that, you would run some sort of multiplexing client on top where you would download a binary that implements the first in forks, start from the very beginning, execute all of those blocks, build up your state database, your history database, and then once you reach the final block that client is able to calculate, it sort of shuts down, writes everything to disk, and then the multiplexer shifts a new binary in that can execute the next in forks, loads the state database and the history, and continues like building up, and then eventually you get to the point where you're running the latest client. And it's not perfect by any means, because the database is probably going to change as you go through things, and you might have historical objects that you need to still show, so you can't delete all the code, but you might be able to delete some old artifacts about, you know, gas accounting logic, how things were implemented in the frontier hard fork, and that type of thing. So that's kind of like an idea that we're thinking about. Still extremely long ways away, 3, 4, 5 years from ever even like really considering something like to happen. But I don't know if anybody else has thought about just being a follow the head client.
Yeah, basically having like a idea where you can deprecate some part of code is very nice. I'm not exactly sure how we are going to get there. Are we going to expire accounts? Are we going to expire the state? How exactly are we going to do that? There's few ideas. But either way, pruning away old code, it is desirable. But yeah, to be honest, I'm not sure how to get there. Because even if you prune old code, maybe there is like some need for somebody to run old code or old blocks or just get the section or just get data or something like that. There's always some need, but I'm not sure where the cutting point is. I think that's the main
that
point.
Makes sense. And for the third kind of, oh, sorry. If you want
I was just gonna agree with him. Deprecating old code that is not necessary to follow the chain is desirable, but I guess it's a blockchain, so we will need it at some point. It is gonna still be needed at some point for some work like archive nodes, because archive nodes will be used and will be needed. They will not just disappear. So yeah, I agree what the guys.
Okay, and as the last, okay.
Just one moment. You additionally have like L2s and everybody that has some their own specification, their own some particular hard fork that they want or need. You still need to support something like that. But yeah.
Sounds good. Yeah, I think maybe as last quick question to wrap this up. I think we've heard kind of quite a bit about kind of the client side and how the challenges, and I think just the limited things we can do there. On the Solidity, on the kind of on the compiler level, on the kind of more user-facing side, are you, beyond just incremental improvements like UF, are you hopeful that in the future maybe we can have some bigger steps towards getting to a better future where we can actually get rid of most of these kinks, or do you think blockchains will just be stuck with this for the rest of times?
I mean, I hope there is room for incremental improvements. Not sure what else to say. I mean, there is a lot of stuff that would, even beyond the most important quirks we have already talked about a bit about for us, that would be nice. Different memory pricing, few segments, stuff like that. but yeah.
Okay, well then let's hope we can get that done. Awesome. I think that wraps it up. So thanks everyone for coming, and have a lovely rest of the conference.